Good day, everyone. Yeah, in this video, what we're going to do today is since we have been able to, with assistance of GitHub Copilot, to been able to formalize each of the lemmas and theorems in lean language. We're not going to do much today. We're just going to assemble them. We're just going to gather them, in one GitHub repository, so that as time goes on, we'll see what the next moves would be, and so just like that, we're gonna get started. And so here. Working on some stuff here. Sorry. Yeah, done. So let's go here. In fact, I think should even go to VS Code. No. Okay. Something I was working on. Okay. We're not going to do this today. I mean, we're not doing. Okay, this was seen from theorem 2.13. So right now, what's the goal now? I'm trying to find AI. Yeah, it's here. So this is theorem 2.10, So let's come here. Should hide this for now. 2.13. So this is lemma 2.10. And so this is it. So in fact, yeah, you're going to GitHub. That's what I'm supposed to do. Okay, let's do this. For clarity purposes, let's create a new repository. Let's create a new repository. You can label it gathering formalizations. Okay, from gathering formalized lemmas. Public. So we create repository. And so we just created it. And what do we do now? So you can either create a new file or upload an existing file. And so let's create a new file. So here, so we have now created a new GitHub. Let's go to this lemma 2.10. This quite not in order, but we are just gathering them. We'll rearrange them. So this theorem 2.10, lemma 2.10, it comes here. So let's leave a mark. So just leave a mark here. You see lemma 2.10 over here. Just leave the mark here. So let's do this. So we are just going to make sure we have all of them together. And so and then for the scroll. This was the finalized version of lemma 2.13, which is the final part. This was the last thing we formalized. This, you know. So this was how it finished it for us. So we copy paste. This was lemma 2.13. Copy, put it here. Oh no. It's supposed to come under. It was the last thing we ever did. Copy paste. So we leave it over here. So this is it. Lemma 2.13 and lemma 2.10. So we'll have to come back and look for the rest. So let's come here. So lemma, okay, 2.9. We did not do this because it already infers from the previous ones. We did okay for lemma theorem 2.9. It talks of there exists no perfect cuboids where any of the sides A, B, and C is a product of two distinct primes. And we covered that for B and C above. And so this is just a theorem or statement we put over there. So let's go on top. So we now have to now go for lemma 2.8. Let me see what's happening. Here's 2.10. This okay, this is lemma 2.9. So I think it polished 2.9 for us. And this is what we have over here. So you can see this lemma 2.9. We copy paste. Lemma 2.9 goes over here. So we have to go to 2.8. Okay. 2.8 with prime side C. Wait. What did we just do? Let's check. No, okay. No perfect cuboid with prime side B. With prime side B corresponds to let's check. So I think that should be from 2.7 and not 2.9. So I think there's a bit of mislabeling. So let's see. Let's see what's happening. Okay, there exists not a perfect cuboid. B equals P for any prime P. Oh, okay. So this, okay, this has to do with lemma 2.7, prime side B, which, what am I saying? With a, there exists not a perfect, okay, when A or when B is a prime, not a biprime. So I'm already mixing things already. So, uh, oh, okay. I think the misnumbering come from the fact that I reshuffled them. So I reshuffled them so that the all the lemmas and theorems, whatever that have got to do with primes, is on one side, and those that have got to do with biprime sides are on the other side. That's where it comes from. So yeah, that's where the mislabeling of the lemmas come from. But yeah, that's it. And so we'll take this. We labeled it as two. We now have it as 2.4. So you can see there exists not a prime, a perfect cuboid with B equals P. So that's now it now corresponds to lemma 2.4. So we copy paste it. Oh, it's already here. It's already here. What am I thinking? It's already here. It's already here. It's already here. And that would mean that, okay, okay. So now lemma 2.10 also changed a bit, because what did lemma 2.10 say here? It says that when C equals P, when C is a prime, when you consider a side of the perfect cuboid where C is a prime. And so let's see. Okay, let's see something. Let's check something. I think I changed the numbers a bit, so it's a bit yeah. By prime A is by prime B by prime C. Okay. Okay, lemma 2.10 over here is what we labeled as two. Okay, okay. So I mean, the best thing would have been to reshuffle the numbers, but it's okay. Whatever changes that have been made, I would address it later. So 2.1, let's see something now. So, so that means that let's try to get some things. So in this paper, this paper was such that I covered areas where you're dealing with a side, whether A, B, or C, is either a prime or a product of two primes, which is a biprime. Some would see this semi-prime. You know, that was how I approached it. And afterwards, I now try to work on the composite case, which is a much more general way of doing things. But once we're talking about generality here, then there's ways that need to be a bit of cautious. And so, yeah, at the end of the day, the goal is to make sure it's all correct. So if there's always the need to reach out to people who know more or people who are more into numbers, their theory, who has worked into this work also. This is how best I could approach this problem. So it would be great to get insights there. And so we'd find out that this lemma 2.4 here covers the side where B equals P, where B is a prime. And what I labeled as lemma 2.10 is when C is a prime, you know. And for the case of when A is a prime, I just label it a prime constraint. So when you come here, I just label it some a prime constraint. That's when you come here, lemma 2.3. That's what I labeled a prime side constraint. That's in terms of A. So let's look for that lemma 2.3 and see. I don't think I made any more changes with that. So let's see. Here's 2.6. No, lemma product of two primes. So we are scrolling. Is 2.4. Product of two primes, no. Is 2.3. This was how this guy approached it. GitHub Copilot. So this lemma 2.3, copy paste it. This is how best it approached it. Yeah, 2.3 goes on top. So this is when A is prime. Then we have when B is prime. And then when you come down here, you have when C is prime. So, and this is also the composite case. So let's go back to the paper. Let's look at the product of two primes, biprime or semi-prime. So that's where you find it over here. Here, no perfect cube, but biprime side E. Product of two primes. Yeah. So this is lemma 2.4. Look, this product of two primes. Yeah. Because that's so product of two primes constraint. Let A be equals PQ. Okay. So this is lemma 2.5 with no biprime side E. That's when A is a semi-prime. The side E is a semi-prime. So let me copy paste this. This is lemma 2.5. Okay, let me see. Oh, you know what? You see this GitHub work? Initially, the goal was to arrange it based on order of the lemmas and corollaries and stuff. But since I changed the numbers, I tried to reshuffle things. I think this is how we're going to order them. The sides where lemmas and corollaries or theorems where the side in consideration, whether it's A, B, or C, are primes first. Those lemmas come first. Then those that are biprimes come next, and the composite ones come next. And so we have A here, we have B over here, we have when B is equals a prime, and when we have when C is prime, and so afterwards we see that we have something about the composite cases. So we have to put this in between there. So let's put this here. So we can leave a hint, something of. Here's how it is. So this is how things are done. This is how things are done. So we now have it for product of two primes when A is equal to P times Q, where P and Q are also individual primes. So let's go for the next one. It's a bi prime. Now, what's the next one? B is a bi prime. So we're supposed to go for lemma 2.7. So let's go for that. Okay. This is what we labeled as theorem 2. Lemma 2.6. So here, assistance of GitHub Copilot, you're able to get. So here it says there does not exist a perfect cuboid with B equals PQ. And that corresponds to this. Okay. So we copy that. So let's come here. So we can somewhat label when B is bi prime. Yeah. So the next one will be when C is a bi prime. That's the next one. In this case, you're now able to account for symmetry. Whatever works on one side, it works on the other side, and yeah. So let's go for when C is a bi prime, and that should correspond to lemma 2.8. Let's see. Okay, okay. This is it. Lemma 2, we labeled it lemma 2.7, but it looks like we changed things now. No perfect cuboid for bi prime side C. So we copy paste this, we change, put it here, and I think that's pretty much that. So let's look at something. We're able to now have when A is a prime, considering this parameterizations like we did, then we come to lemma 2.4. Here, it's supposed to be when B is a prime. And then we come here. When C is prime. And then we're now dealing with bi prime. So when A is a bi prime, B is a bi prime, C is a bi prime, and now we're having to deal with the, given A is greater than or equal to 1, we dealt with all of this. The assistance of GitHub Copilot, and I don't see. What is this? What did Lemma 2.9 say? Jeez, the battery's low. Oh, B is prime. Okay, okay. B is very something. Okay. Okay, I think B is equals to when B is a biprime. I think we're considering that in terms of this new approach. I think when you come down to this approach, because how we try to prove that perfect cuboids do not exist in giving contexts. We come down here, we try to link it to Euler's parametrization for Pythagorean triples. And so based on that, that also made us approach that same thing differently, but sort of further reinforcing how we approached it before. Yeah. Okay. Let's go before this and see. So let me see. This is what we have been able to do. So I think we have so far been able to compile all of the lemmas, the necessary lemmas. Yeah. And also let's okay, wait. Let's not forget something either. Okay, lemma 2.2 and that of okay, lemma 2.2 and 2.1 is true. That's how we're about to end the video. Let's go record this. I'm gonna keep scrolling. Device constraints. That's how we did it. So lemma 2.2. I did not change that one. Yeah, so divisor order constraint, we see it here. So we copy paste. Lemma 2.2. Yeah. That's got to do with the ordering. Certain orderings of devices necessary to keep strike a certain balance. Because let's see, if all of the unknowns that we're looking for have the same device, that means they're the same. All the numbers are the same, which is degenerate and does not make sense. Right? We have to keep certain orderings, like ensuring that the divisor for the space diagonal is as small as, because the smaller the divisor, the bigger the number in itself. And so that's all of what this encompasses. And so um let's go upper, let's go, and monotonicity and stuff like that. So this covers lemma 2.1, lemma 2.1. So it is able to, fill all of the necessary gaps. So copy paste this. Yeah. to the mark here, same lemma 2.1. So I think, yeah, let's name this. Let's make it a very geeky name. So I think we have now accounted to the best of our proven ability, lemma 2.1, 2.2, 2.4. We have now done this. But I still think so. The reshuffling will still be necessary. We still need to do some reshuffling of these names because I want to make sure that there's some sort of coherence. Right now this is still a paper where I'm trying to work on. So yeah, all of these things. Yeah, there's not really any restrictions we can make as long as the work is correct. Yeah. So. Next, we should just get to yeah. I think the purpose was just to gather everything. I don't want to go beyond what I've planned for this video. So on this note, thanks for your time and thanks for staying with me, watching till the end. Yeah. Just ciao and see you next time.